There it goes. All right, so inequalities. I can't even remember what we did last time. Did we do inequalities? No, we haven't done inequalities yet, have we? Okay, we've been doing them in Algebra 2, so I'm trying to keep it straight. Which class that we... So we are taking a test on a bunch of inequalities in that class pretty soon. So anyway, let's see. Yeah, I'll just teach you the inequality thing as we do the example. So let's kind of do a non-example as an example, I guess. They don't really call it an example, it basically is. So I'll just draw my own graph. Let's do this. Let's grab this graph right here. I don't have to be super accurate with it, so I'll just use this one. And there we go. That looks a little bit better. If I can grab it, there it goes. All right. So let me graph something pretty simple. Let's go greater than. Negative, whoops, come on, pen, help me out here. Let's make this look a little nicer. Y is greater than negative 1/2 x plus 2. Forget the greater than just for a minute, okay? We're going to come back to it because that's what this whole lesson's about, all right? Can you move your desk up a little bit so he doesn't kick it or whatever? Just lift it up. There you go. All right, if I was to graph this, we should all know how to graph this. What if it was an equal sign? And I asked you to graph it. Y equals negative 1/2 x plus 2. Should be able to do it pretty quick, right? 2 is the y-axis or the y-intercept. So we dot right here. The negative 1/2 is the slope. So what do? Rise 1 and run 2. Yes? Now normally we would do what? We would connect the dots, correct? But this time it's an inequality. We're trying to find all the values that are not equal to negative 1/2 x plus 2. We're trying to find the values that are what? In this situation? Greater than, all right? And it's not or equal to. If it was or equal to, then we could put a solid line. You probably did this in Algebra 2, I'm sure, all right? You could put a solid line, but we're not going to put a solid line. I think, I'll tell you what, I'm going to put a solid line, but I'm going to try to change it to a dotted line. I haven't done this on this program. I think you can do it pretty easy. So let's do this. I think if you go to here, and you go to, nope, not that. It's not what I wanted. Let's see this. Nope. Style, maybe. Give me a second. Don't lose me. There's got to be a way to make it dotted on here, but maybe it was another program, so I am not going to draw a solid line. I'll just freehand, right? Boom, 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 boom. Everybody see? And then we'll go like this. Why do I make it dotted? Because we want to find everything that's bigger or greater than this thing right here, not equal to. If I did a solid line, what do you think that would mean? It means it would be equal to. That's right. So I do a dotted line. Is that it? Do I just put the dotted line and I'm good to go? No. I got to figure out what values, okay, what point will satisfy this inequality. All right? That's a big fancy math way of saying, let's figure out which numbers work, okay, which points work. So let's just don't pick a point that's like super close to the line. Pick a point that is definitely either above it or below the line. So let's pick like, I don't know, a point right there. Just any random point in any of this. I'm not going to pick anything super big, any crazy. So what do you think that is? 2 what? 4 maybe? Okay. So let's put that in there. Let's choose 2, 4. All right. All I did was pick a point that is above that dotted line. That does keep on going, by the way. All right. You see what I just did? I could have picked a point here, picked a point here, 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 way out there, but I just picked something that I knew was reasonable. All right. So I know that 2, 4 is definitely going to be above that line. Agreed? So let's put it in and see if it works. So what is that? What do I mean by put it in there? plug what in there? What in for y? What's my y going to be? 4. Everybody watching? So I put a 4, and then put greater than negative 1/2 times 2, and then plus 2. Let's see what that is. What we want to do is I want to see. I'm doing a test. I'm testing to see if that point is a point that I want to include in my answer. You'll see in a minute how it all works out. What's this going to be? Negative 1/2 times 2, so the 2's cancel. That's a negative 1, correct? Yeah. Negative 1 plus 2 is 1. Okay, here's what we're looking at. Is 4 greater than 1? Yes. Yes, it is. Not a hard question. 4 is bigger than 1. All right, so we learned that in pre-calculus. 4 is bigger than 1. It is true. So that means that any point above the dotted line, because 2, 4 is above the dotted line, right? Any point above the dotted line will satisfy this inequality, will make the inequality work. Okay, 4 is greater than 1. It makes it work, doesn't it? The 0.24 satisfies that inequality. That's what they say in math all the time. Or it just makes it work. All right, so what we can do is we can shade that whole entire region above the dotted line. All right, and depending on how well you can shade, this is my shading. All right, so I'm just putting a whole bunch of lines. That means anywhere in the shading part is a valid answer for that. So that's the graph. It says graphing linear inequalities. So this shading is my answer. Okay, the graph, it's got to go in the right direction. It's a dotted line, and it's any point above that dotted line makes that thing work. If you don't believe me, let's pick a point below the dotted line. What's a really easy point to pick that's below that dotted line?
0, 0.
0, 0 would be the easiest, wouldn't it? Would you agree? So let's try, listen, let's point in, and is that the only point that's below that dotted line? Nah, there's a million of them, okay? More than that. There's an infinite number of points, but that's an easy one, 0, 0. So let's go back to this inequality.
I don't know.
All right, let's put it in here. So 0, 0. So I put a 0 in for that. I don't want to write in green. Oops. Let's write in whites. Okay, come on. Let's put it in here. So put 0, put greater, negative 1/2. I'm going to do the whole thing for you so you see what I'm trying to do here. All right, you know that's going to go to 0. So 0 is greater than 2. Or is it? Is 0 bigger than 2? Obviously not. So that doesn't work. So can I pick a point that's below that dotted line? Nope. I can pick any point below there, and it's not going to make that inequality work. Okay, it's not going to satisfy that inequality. Everybody got it? So only the points above the dotted line are valid answers. And that's how you show it. You show it by shading it in. Make sense? Yeah, not too hard. It is easy. This is probably, it's the last lesson of the chapter, but it may be the easiest lesson of the chapter, to tell you the truth. And I'm not just saying that. All right, which is actually good for you, right? You like to end with an easier lesson. This is an actual example. This is example 1 in the book. And here's what it says to do. It says to graph x is greater than 3. Okay? So where do we start? Well, what's it going to look like? What if it was x is equal to 3? What would that graph look like? They're all straight lines. Is it horizontal? It's vertical. Goes through the x-axis where? At 3. Okay? So it goes through right here. Normally, we would do what? Just make a solid line, right? But we're not going to do a solid line. Why not? It's not or equal to. What if, now this problem doesn't have it. I think the next one does. Okay, yeah, the next one does. But what if it said greater than or equal to? Then it would be a what? A solid line. Okay, but it doesn't say that. So what do we draw? A dotted line. I'm going to start here. Boom, boom, boom. And it's, oops, that's not very vertical. You get the idea. All right, that one's a little bit better. There you go. So there's the dotted line. Now, it says x is greater. Now, this doesn't really have above and below, does it? So what points do you think would satisfy this? All the points that are greater than 3. After 3, to the right. Since it's vertical, we'll go everything to the right of 3. Let's just check to see if it works. I mean, it's an easy check, right? Pick 4. Is 4 greater than 3? Yeah. Pick -2. Is negative, or not -2, but pick 2. Is 2 greater than 3? No, it's not. So where am I shading? I'm shading to the right. Well, it's still my right, because I'm writing it this way.
I'm sorry.
All right, so that's your answer for that. So if it's a vertical line and it's greater than, we shade to the right. If it's got a slant to it and it's greater than, we shade above. What if it's a slanted line? What if it's a slanted line and it said less than? Then we shade below the line. Makes sense, right? I haven't said that yet, but hopefully that would make sense. So let's do another one. Let's do this. All right. And this one's a little bit more involved than that one. That one was pretty easy. But you should know what to do with this. There you go. And it says to graph this. Okay, I'm not going to write it on there, but they all say to graph. So what if you wanted to graph that right there? What would you do? Good. Put it in the what? Slope what? Intercept form. Good. So that means we solve for, what do we solve for? X? Solve for y. We want y equals mx plus b. All right? So let's get the x on the other side. Let's get the minus 5 on the other side. And then at the very end, we'll get rid of the -2. All right? So just do a little bit of basic algebra. Keep the less than or equal to. Subtract x from both sides. That gives you a minus x. Yeah? When you multiply or divide by a negative is when you change the sign. Okay, or the direction of the inequality, I should say. Add a 5 to both sides. Did I record this? Yes, I did. Okay. Just making sure. All right, so add a 5 to both sides. Yeah? Now we divide by -2. Now that's the thing right there. When you're dealing with inequalities, I think it's the first time this year, isn't it? We've dealt with inequalities. Am I right or not? I think so. Yeah. If you multiply or divide by a negative, shh, stop. Would you settle down? So when you divide by a negative or multiply, in this case we're dividing by a negative, then we have to change the direction of the inequality. So now we divided by a -2, so instead of a less than, what do? Change it to greater than or equal to. Still keep the equal in there. And now we can do the rest. What's this? That's positive 1/2 x. I'm going to write the 1/2 out in front because I want to see what the slope is. Plus 5/2. We have to plot 5/2, so I'm going to change it to a mixed number. This is a time where I would definitely want to change it to a mixed number. Yep, negative 5/2, just like I said. I didn't. So it's minus what? 5/2. But let's write 5/2 as a mixed number because that's a little easier to plot on the graph. What's 5/2? Just 2.5, right? Everybody's got that, right? That's pretty easy. All right, so now we go ahead and we plot. Now, it's or equal to, so now this time, guess what I can do? I can keep it a, what kind of line? Solid line. All right, so -2.5, there's -1, there's -2, there's -3. -2.5 would be right there. What's the slope? 1/2. Well, it's 1/2, right? 1/2, that's correct. So you rise 1, right? See how you're in between here at a half? So you go up 1 full 1, which would still be half, right? And then you go to the right 2. All right, so there's my rise 1, my run 2. And now we connect them with a solid line because of that or equal to. If it didn't have the or equal to, if it didn't have the or equal to, then we would make it dotted. And we'll put arrows on the end. Now that's not my answer because it doesn't say what's equal to this. It says what's greater than or equal to it. So where do we shade? We shade up here or down here? You can tell by this. Do we shade above or below? What is it? Is it? Are you asking me or telling me? You could. You could check it. All right, but you kind of see what we did before. That's it. It's greater than, so it's above the line. All right? If it's greater than, it's above the line. What if your line was vertical? It'd be to the what? To the right of the line. All right? So greater than means above or to the right. So I could just shade. What if you were doubtful? And some of you guys seem to be a little doubtful. 0, 0 is a great point to pick because it makes it really easy and it's above the line, right? It's definitely above the line, so we don't have any question about that. So let's see if that works. 0, 0. 0 greater than or equal to. 1/2 times 0 is 0, so that's negative 2.5. Is 0 greater than negative 2.5? It is. That's true. So this satisfies the inequality. All right? That means every single other point above that line is going to satisfy it. All right? So I can shade all that in, and that's my answer. All right? Don't go nuts on the shading. Don't shade all the way to the edge of your paper or anything, right? But make it, make it look like you know what we're talking about. All right? If you really wanted to, listen, if you wanted to, you could pick a point down here somewhere just to see if that works as well. Let's just pick one. Like, where we go? Like negative 2.5, right? So let's go 0, 3. Let's pick a point right here. That's definitely below it. What? You came in late and you're leaving early? Let's do this problem first. Watch. So what would this point be right here? It's just below the line, but it's an easy point to pick. It's what? Yeah, but that's the point. X and a Y. It's not just negative 3. What is it? It's 0, negative 3. Okay? So let's put that in for this. So what is Y? Negative 3. Greater than or equal to 1/2 times the X, which is 0, and this is negative 2.5. Is negative 3 bigger than negative 2.5? It's not. Negative 3 is smaller than negative 2.5. So can you pick any points below the line? No, they won't work. So if you want to do a test, you can. But you should be able to do these, right, without even doing a test. But if you're not sure, absolutely. Pick a point that's obviously above or below. See which ones work, which ones don't work, and then shade in the direction of the ones that work. Everybody good? All right. If you girls have to go ahead. I've got a couple more examples, 2 more examples to do. All right. This graph is a little bit weirder. Did we do absolute value in here? I know I did in Algebra 2. Okay. So did we graph an absolute value? Yeah. Okay. Good. Because that's what we're going to do right now. You're welcome. So this is part C, still example 1. This is part C. So it says y is greater than absolute value of x minus 2. You could, I can't remember. Again, I get confused. When I teach the same topic in 2 different classes, I can't remember what I said in what class. I know I did this in Algebra 2 for sure. Did I show you how to graph this? So you know what a y equals, let's just say equals. Y equals absolute value of x. It's that v looking thing. What does that minus 2 inside there do to us? It takes that v and it moves it where? To the right 2 places. All right. So, but we haven't officially taught that just yet. So let's go back to the beginning when we did this stuff. All right. Now, in my mind, and we've already talked a little bit. Okay, you kind of know that it's gonna start right over here. All right. So let's put some points in there. Let's put a 2 in. Let's put a 2. All right. And then let's put, well, I'll tell you what, let's go negative first. Is that all right? So let's put a -1, a 0, a 1, a 2, 3. Yeah, that should be good right there. All right, why did I pick those numbers? They just seem like random numbers, but I kind of know what this is going to do because we talked about it before. It's going to shift your graph to the right 2 places, so I know I'm going to pick that point right there. So hopefully 2, 0 works. All right, let's see if it does. Put a 2 in for x. Well, 2 minus 2 is 0. Absolute value of 0 is 0. All right, so yeah, that does work. So let's pick a couple points to the right, or at least one. Let's pick 2. Put a 4 in there. Okay, so this is 1, 2, 3, 4. That's 0. It's -1. All right, let's do that. So let's put some other points in here. Let's put a 1 in there. So 1 minus 2 is, what's 1 minus 2? -1. The absolute value of -1 is 1. Okay, so when I put a 1 in here, what do I get? I get a 1. Let's put a 3 in for this. 3 minus 2 is 1. Absolute value is 1. Do you see how this is kind of like your middle point and it kind of grows from there, right? It goes this way and it goes this way. Put in a 0 for x. 0 minus x is -2. Absolute value of -2 is 2. All right, that's good enough. Let's put a 4 in there. 4 minus 2 is 2. Absolute value is 2. Okay? I don't even need that -1 because I kind of get an idea of what this is going to look like. All right? So let's do some different color. Red. All right, I already got the 2, 0. We'll make it red this time. All right, what was the 3? 3 what? 1 and 4, 2. Right there. All right? The other side is just going to be a mirror image of it. You see that? I went over 1 and I went up 1. So what am I going to do here? I go over 1 this way and I go up 1. To get to the 4, I went over 2 and I went up 2. From the 2, I go over 2 to the left and I go up 2. So it looks like that. Now, it just says greater than, doesn't it? So what kind of line? Solid line or dotted line? Dotted. It just says greater than. It doesn't say or equal. All right, so a dotted line this way and dotted line this way. And we'll kind of make it look the same on the left and the right. And that's your absolute value graph. But it doesn't say y equals the absolute value of x minus 2, does it? It says y is greater than. So where do you think the greater than is here? So this is a little different because you don't just have one line and above and below, but you kind of do. It's 2 lines. Yeah, you got like inside the V and outside the V. All right. So let's pick a number inside the V that's pretty easy. Let's pick one outside. Okay. So what is it? 0, 0. That's the easiest one to pick. So let's put it in there. This is our test point, okay? I just want to see. If the 0, 0 satisfies that inequality, if it makes that inequality work, then we shade everything outside of that V. Okay? If it doesn't, that means we shade everything where? Inside of the V. You got it? So let's do it. Put 0, 0. So what's that? 0 greater than. Put a 0 in for this. 0 minus 2 is -2, but the absolute value of -2 is 2. Is 0 greater than 2? No, it's not. 0 is not bigger than 2. So do we shade where the 0, 0 is? So where do we shade? Inside the V. All right? If you're not exactly sure about that, pick a point that you know is inside that V. Pick like, I don't know, 2, 2. 2, 2 would be right here, wouldn't it? That's definitely inside that V. Let's see if it makes it work. So let's put it in here, 2, 2. So I've got a 2 greater than absolute value, 2 minus 2. I don't even have to put that up. We can do this in our head. 2 minus 2 is what? 0. Absolute value is 0. 0 is 2 greater than 0. Yes, it is. So any point inside of that V, right there, anywhere inside that absolute value, okay, is gonna make it work. So that's what you want to shade. That's how we do it. I told you it's pretty easy, right? Let me do one more. All right. Okay. All right, this one looks a little different. This will test if you really know how to do your inequalities or not. -1. Better write this down. This one's a little tougher than the ones we've been doing. In fact, oops. I'm going to move this over just to give me some room. All right, here we go. Now look, this is called a compound inequality. We talked about this in my Algebra 2 class, but we did not graph these in my Algebra 2 class, the compound inequalities, with x and y. We actually did it, I think, with just one variable, but not with like a whole line. We just did it with points on a flat x coordinate number line, okay? So this is definitely a step above the Algebra 2 stuff, but it's very similar to what we did. What does this mean? For instance, watch this. -1, these numbers have nothing to do with this right here. I just want you to see it. Instead of x plus y, watch what I'm going to do. X, 3. What does this mean? This means x is what? It's between, right? That's what I wanted to hear. It means x is between -1 and 3. Everybody see that? It means it's less than 3, but it's also what? Greater than -1. So that means everything in between. Everybody got that? So you kind of know what that means in the middle. Now, when you do inequalities, this compound inequality, you could write it as two completely separate inequalities. You could write it like this. -1 is less than x plus y, and you could also write it, what do you think? I did the hardest one first. Yeah, x plus y is not greater than, it's less than or equal to 3. You see that? These two things right here mean this. This is just a combination of those two. So what we're going to do is actually graph not just one line, but how many? 2 different lines, that's right. And I want to get y by itself. So right here, how am I going to get y by itself? Well, let's subtract an x from both sides. So what are we going to get? -x minus 1 less than what? Y. I want to get the y by itself, but do I really want this y on the right-hand side? You guys watching? Watching me. Don't watch Braden. He just walked in the door. That's all he did, and he sat down. All right? Everybody look up here. So I want to get y by itself. Well, y is by itself, but I like it on the left-hand side. Just makes a lot more sense. So how am I going to write this? Y is what? Read it from right to left. I could read it what? Y is greater than
1 minus x.
Yeah, let's do the x first, though. -x minus 1. Do you see how this thing and this thing is exactly the same? So what I'm going to do is I'm going to graph this, and I'm also going to graph this. Now this one's a lot easier, only one little step. Subtract x from both sides. I don't have to change any signs or anything like that. So what I'm going to do is I'm going to graph both of these things right here. And let's see what we get. Now, let's see. Yeah. So this one's going to be a solid line. How do you know this one's going to be a solid line?
Because it's greater than or less than equal to.
Because it's or equal to. What about this one?
Dotted.
It's just going to be a dotted line. So one's going to be solid, one's going to be dotted. So let's just graph them both. All right. So here we go. Let's graph this. The y-intercept is 3. 1, 2, 3. Put a dot right there. Okay. The slope is -1. So what do? Let's go down 1. Is that all right? Down 1 to the right 1. Or I could go up 1 to the left 1. Yeah? This is or equal to, so guess what I can make this? A solid line. All right, what about this one? Y is greater than -x minus 1. So the y-intercept is -1. The slope is -1, just like the same slope of that. So guess what's true? If they both have the same slope, then what's true about those two lines? They're parallel to each other. So let's rise 1, run 1 to the left. Now I'm not going to put what? A solid line, because it just says greater than. It doesn't say or equal to. I'm going to try to make that look parallel. Doing these dotted lines by hand. It's not that easy. Okay, that's close enough. It's supposed to be straight. It's a little wiggly, but you get the idea. Now, here's the situation. Do you see that word and? That's super important. We're trying to find the intersection of both of these. Okay, what works with this and also works with this? So it's got to be between both of them. All right, it's got to be the intersection of them. That's what the and means. So let's just do the dotted line first. Where would we shade if all we had was that dotted line? We didn't have that solid line. We'd shade what? Above or below? Are you guys listening to anything I'm saying? Somehow I don't think you are. Where do we shade? It's x is greater than negative x minus 1. What if that's our only line on here? Just the dotted line. Where would we shade? We shade everything above, correct? But remember, we're shading two things, and we want to find where they intersect each other. So this isn't necessarily going to shade forever. It's in between, because this is what? The solid line is less than. So we're going to shade everything what? Below. So what we want to do is find the intersection of everything above the dotted line and everything what? Below the solid line. Okay, and where is that? It's just all this. Okay, so that is where they intersect each other. We actually have three places that we could check, don't we? Oops, let's, what did I do? There it goes. Okay, let's check 0, 0. So 0, 0 should work, correct? And it should work for both of them, right? Not just for one of them. So let's put 0, 0 in for this. So 0 is greater than negative 0, which is 0 minus 1. Is 0 bigger than negative 1? Yes, it is. So does that work?
Yeah.
Yep, it works for that one. Does it also work for the other one? It's got to work for both of them. So put 0, 0 in for that. So that's 0 less than or equal to. Negative 0 is 0 plus 3 is 3. Is 0 less than or equal to 3? Yes, it is. So does it satisfy both of them? Yep. So that means everything in between is correct. If you wanted to, I'm not going to do it, but if you wanted to, you could pick a point. Let's do it. Let's pick this point right there. That's definitely above that line, right? And let's see if it works. So what is that point? 1, 2, 3, 4. So that would be what? 0, 4? Let's see if that works for this one. Let me erase these. Erase these. All right, so 0, 4. So what is the y? Is that the 0 or the 4? It's the 4, right. 4 greater than. Again, negative 0 is 0 minus 1. Is 4 bigger than negative 1? Yeah, it is. Wait a minute. I thought it's not supposed to work. It works for this one, but it's also got to work for this one, right? Let's see if it does. All right, what are we going to put in for the y? 4 less than or equal to negative what? 0. Is 4 less than 3? It's not. So does this point work for both of them? No. It has to work for both of them to be included. All right? And you could always pick a point down here somewhere if you wanted to. You're going to find out that it works for this one, but it doesn't work for this one. All right? So that's how you can kind of test to see what are you going to shade. Have you ever seen that before? It seems like that would be an Algebra 2 topic. It seems like it. I keep saying that all the time, don't I? But it just depends on how far you go in Algebra 2, I guess. I don't know. So let's do some homework on this. So it's section, and I know you got the retreat tomorrow, but tonight you got homework. So get it done tonight. Don't wait till tomorrow, all right? Because you might get late. You'll probably be dead tired when you get home. You probably just want to go to sleep or play your video games or whatever you guys do. And all right, so there's your homework. And that's the last one of this chapter, last homework of the chapter. And that's it.